Hello everyone, this is the first lesson recording for day 7 and we're going to be tackling powers of complex numbers. So to begin, we are going to start with exploration. So here I have a complex number in rectangular form. If I have a complex number and I want to raise that to the power of 7, in rectangular form what it means is 3 plus 5i being multiplied to itself 7 times, right? We need to do that 7 times, right? So how do I do that? In order to calculate this in rectangular form, I would want to multiply this first and use FOIL, multiply this, and then come up with a new complex number and then multiply that new complex number with another complex number and get the new complex number, and so on and so forth. Okay, is there an easier way? Yes, there is an easier way, especially if it is written in polar form. And so the driving question right now is there a pattern for finding powers of complex numbers in polar form? And to do that, we are going to start with this worksheet that you are going to receive in class. And this is the one that says your complex numbers and so on and so forth. It's the whole sheet. And you're going to be working on that. You can work on it as individual or as group. So if you're working as a group, you can put the group member's name. Okay, so here are the equations, that the complex numbers that you're going to be choosing. If your last name starts with A to C, then this is your complex number. If your last name starts with D to F, then this is your complex number, and so on and so forth. Okay, so you can just pause the video, figure out what your complex number is, and then you are going to write it right at the top right here. It says complex number Z, and you're going to write that here. I am going to demonstrate how you should be doing it using this number. Okay, but if you feel you can do the rest of the paper on your own, feel free to pause the video and see what you can do. And if you ever get stuck, you can come back to my video, because what I am going to do is I am going to demonstrate what to do if my complex number was this. So here we go. So my complex number was 3 minus 3i. And if I was to do a quick sketch of this, it would be, there's my real axis, and this is my complex axis. 3 is positive 3 minus 3i. Minus 3i, this is positive 3 and negative 3i will be right here. Okay, so we are dealing with a complex number in quadrant 4, right? Okay, so then standard form is 3 minus 3i. Trig form is same as the polar form, and that's in terms of r cosine of theta plus I sine of theta. That's my trig form. And so in order to figure out what my trig form is, I need to figure out what radius is and what cosine the theta is. So I need to figure out what this distance is as well as what is this angle right there. Okay, so to figure out what is r, remember the complex number is a plus bi. Radius is always square root of a squared plus b squared. So that's going to be 3 squared plus negative 3 all squared, square root of it. And that is same as 9 plus 9, which is 18. And I am just going to leave it as square root of 18. Yes, I can simplify this to 3 root 2, but for the sake of seeing the pattern, I'm just going to leave it as square root of 18. So that's going to be square root of 18. What about theta? Theta is going to be inverse tangent of b over a, and inverse tangent of b, in this case, is negative 3. Divided by a is 3. So that's same as inverse tangent of -1. And if I use the calculator, I get theta to be -45 degrees. Or I know actually what is the angle measure that gives me tangent to be 1 is 45 degrees. And the calculator is giving me -45 degrees because it thinks that we are either in, because it's negative, it's only going to give us the angles in the quadrant 1 and 4. And it's true that it happens to be in quadrant 4 and not quadrant 1. So this works out to be just right. So this is going to be, theta is -45 degrees. So I can write it in shorthand form, cis -45 degrees. Okay, which just means cosine of -45 degrees plus I sine of -45 degrees. All right, so modulus. This is a word we haven't used very often. Modulus is another name for radius, r. So when I say what is modulus, it's asking for r, and in this case, square root of 18 is my modulus. Argument is another name for the angle measure theta. So argument, we can say, is -45 degrees. All right. So now let's keep moving. We have to use the product formula to find z squared. Okay, leave your answer in trig form. So in order to do z squared, okay, so now we know what it will look like when we're dealing with rectangular form, but we're dealing with polar form. Okay, so what we're doing is we are multiplying square root of 18 cis -45 degrees, multiply that by the same complex number, cis -45 degrees. Okay, and remember the product formula from last class. When we were multiplying one complex number in polar form by another complex number in polar form, all you need to do is multiply the radius, or in this case modulus. We're going to start to use the word modulus, and add the argument. You just need to add the arguments. Okay, so in this case, what do we need to do is we just need to multiply the modulus, which is square root of 18 times square root of 18. That is same as square root of 18 times to the power of 2. And for the argument, we just need to add the angles. So it becomes cis of -45 plus -45. Okay, and that is same as 18 cis, okay, -45 plus -45 is really -90 degrees. Okay, all right, so what is the modulus of the product? In this case, modulus is this number right there, that's 18. What is the argument theta of the product? That's -90 degrees now. Use the answer from question 1 and product formula to find z to the power of 3. Okay, so we have z squared is this. So to find z cubed is going to be z squared multiplied by another z. So z squared was 18 cis -90 degrees. And to that, we just need to multiply another z, or another of these numbers. So we are multiplying square root of 18 cis -45 degrees. Okay, and we're again multiplying, so that just means we need to multiply the modulus with modulus. That's going to be square root 18 multiplied by square root of 18. And cis, we just need to add the arguments, right? So it's -90 plus -45 degrees. Okay, and that becomes 18 root 18 cis -135 degrees. Do you start to see the pattern? Well, for the modulus, we are just multiplying by square root of 18 over and over again. So the modulus, the resulting modulus is 18 root 18, and the resulting argument is -135 degrees. And what pattern do you see for the modulus? Okay, with the modulus, you are just squaring the modulus over and over again. So in this case, with the z squared, we just squared it. We just squared the modulus. So it was square root of z, square root of 18 squared became 18. Z cubed was, with the modulus, we were raising it to the power of 3. So we are raising the modulus to the power, whatever power we're dealing with. If it's to the power of 3, we are raising it to the power of 3. If it's squared, we're raising it to the power of 2. Okay, so we're raising the modulus to the power. What pattern do you see for the argument? Well, we're just adding the argument over and over again, the same argument. Or we are multiplying, so we are adding the same modulus by the same number of power. Okay, or so we can say adding argument, the let's say to the power of the same, adding the argument, how can I put this, n times, or to the power times the number of power times. Or we can think of it as we're multiplying the argument the same number of power. Okay, so using the pattern found in question 3 to predict the answer for Z4. So using the same pattern, I'm thinking Z4 is going to be really, what was the original modulus? Was square root of 18. It's going to be square root of 18 to the power of 4. And the argument is going to be really negative 45 degrees added 4 times, or we can think of it as being multiplied by that number. Okay, so in z to the 4. Okay, so then in that case, if I was to find z to the power of 12 in this, so z to the power of 12 for my example, it's going to be square root of 18 to the power of 12, and cis negative 45 degrees multiplied by 12, and this is same as 18 to the power of half. Square root is same as raising to the power of half. Multiply that part to the power of 12, and cis negative 45 times 12 is negative 540 degrees. Okay, and this number here, 18 to the power of half to the power of 12, so they cancel to become 18 to the power of 16. So that is 18 to the power of 6. I'm sorry, I meant to say 6, not 16. And cis of negative 540 degrees. Negative 540 degrees is really, you're going, this is 360 degrees, another 360 degrees. So now 360 degrees is to here. And then we are doing one more half circle. So we're doing 1.5 times the full revolution, so we end up right here. Okay, so that's going to be same as cis negative 180 degrees, which is same as cis 180 degrees. Okay, so that is same as, okay, 18 to the power of 6 is going to, if you use the calculator, you get this huge number, 34012224. And that, if I multiply, expand this form, that becomes cosine of 180 degrees plus I sine of 180 degrees. And this is negative 1, and this is 0. So this just becomes negative 34012224. Okay? Alright, so then see if you can generalize what we've discovered in the theorem. Okay, so see if you can figure it out for the nth term.